Okay, guys, if you were struggling using that chart to set up your equalities, make sure you jot down that question and ask when you're face-to-face with me in class, or send me a remind and we'll hook up on the Google Meet to make sure that you're good and ready to move on to this next portion. If you're good to go, let's get into this. Okay, so now that we understand that this metric chart here tells us the equalities and how many of the base unit fits into the prefixed unit, I want to introduce some of the common base units that you'll see as we move through this course, and also kind of introduce some of the things you might see as you move through physics. So the most common length unit that we use is the centimeter. And then once you understand that the base unit is the meter, and I said centimeter, didn't I? I meant meter. Once you see that the base unit is the meter, I now can create a whole bunch of other units by adding a prefix. Mass is going to be the kilogram, usually, but for chemistry, so in physics, this is the base unit for mass when you're measuring things. In chemistry, we use the gram because remember, we're dealing with really small portions when we're in the lab or even in real life. We're dealing with the gram for the most part. So physics is more the kilogram. We're dealing with the gram. Time is in seconds. Electrical current is called the ampere, the big A. You might remember that in physical science when you work with circuits. Temperature in chemistry is the Kelvin. The amount of substance, so how much of something is in something else, we call the mole. And we have a whole special unit on the mole, so we'll get into that way later. And then luminous intensity is called the candela, like how bright or dim a light is. All right, so remember, all of these base units, except this one, will fit right here at that blue line because that's 1. All right, that is your base unit line. I also told you that the prefix is always going to have the 1 next to it, and the scientific notation and the regular standard notation multiplier equals the base unit. So how many of the base unit fit into that prefixed unit? Now, it's a basic pattern when we're converting between any of those units. So you can go from exa into peta, you can go from mega into micro, you can go deci into centi, you can go any which way in the table, but you're always going to follow the same pattern. So I'm going to draw right here a little map to kind of help explain how we set up these systems. So in order to go from any prefix into any other prefix, you must also first go through the base unit. So what happens is, I'm going to draw this little chart here. Okay, I've got a square. This is going to represent my large units. So my large unit square here, those are these guys. Okay, and then on the other side, I'm going to draw, we're going to have my small units. Okay, and in the center, we're going to have my base unit. All right, so this is a little conversion map that we're going to use. And you're going to like this map because you're going to see it when we do mole conversions later on in the course. All right, so what happens, just like a road map, there's a specific direction that we are going to do and go when we're going from unit to unit. All right, so I can always go from a large unit into a base unit, and I could go from a base unit back to a large unit, okay? For a small unit, again, I can go from small unit into a base unit, or I can go from the base unit into a smaller unit. All right, so when I set that up, you can see we've got a very specific roadmap. All right, so I can go from one large unit into the base unit and then back into a different large unit. I could go from a large unit into the base unit into a small unit. I could go from the small unit into the base unit back to a small unit, and so forth. So I'm just going to follow these arrows when I'm going. These arrows are going to represent how many fractions you're going to need or how many equalities you're going to need to get there. So it's very simple map that you're going to that's going to help you realize the pattern when converting within the metric system. So let's say, for example, I wanted to, I'm going to take some of these here so there's not so much writing. Let's say I wanted to convert between the tera and the hecto. All right, so the tera and hecto are both larger units. Okay, so let's say I'm going to start out in the tera and I want to go to the hecto. So I'm going to convert between these two units. All right, I'm going to have to follow my roadmap. So my tera that I'm starting at, and there's only one R. Oop. All right, we're starting here, and we're going to end at the hecto. Okay, now in order to get there, I'm going to have to follow my map. So if I'm starting at the tera and I want to end at the hecto, I'm going to go into the base unit first. So I'm going to convert, I'm going to find the equality that gets me into the base unit, and then I'm going to take it from the base unit back into the hecto. So I drew two arrows, so I'm going to use two equalities. So what equalities are I'm going to use? Well, I'm going to use my chart. So the first off, if I remember right, remember when we talked about this, our equalities are within the chart. So if I look here, for every one tera, let's say gram, we'll use the gram as our base unit here, there are 10 to the 12 grams. Okay, so there's one equality. All right, so now I'm going to need the hecto. So I look here on the chart, and I can see the equality that I'm going to need is for every 1 hectogram, and that's a small h, isn't it? So for every 1 hectogram, I look there is 10 to the 2 grams. Okay, so I can now go ahead and set up my dimensional analysis by using this chart, and it told me exactly the two equalities that I needed by following this roadmap.